Okay, what we want to do now is performing mutation, but using routers. And when using routers, we don't have table maps. So we have to break down the table map mappings into class maps. So let's do the mutation when traffic comes from network V into network A. So we're going to configure router A. So I'm going to create several class maps now. So for instance, class map, and I'm going to call this AF11. It is going to match all traffic that arrives with a marking of AF11. And I'm going to create several, for instance, AF21 that matches traffic that arrives with the marking of AF21. Also, I'm going to create a class map that is, I'm going to call AF31, that is going to match all the traffic that arrives with marking AF31. I could use whatever name I want here, but just to be able to know what class map I am referring to, I am going to use the same name for the matching and for the class map. So class map AF41 is going to match all the traffic that arrives with a marking of AF41, and then my class map EF is going to match all the traffic that arrives with the marking of EF. Then I'm going to create a policy map that will be the child policy map. It is just a placeholder. You can do whatever you want with this child policy map. We are going to use hierarchical quality of service configuration. So we are going to create a parent that is going to create to do the mutation from V to A. So at each, and then I'm going to use every single of my class map that I just created. So for class map AF 11, I am going to remarket this traffic as CS1. And then I'm going to call the child policy map. Okay, for the next class, I'm going to remark it as CS2, and I'm going to call the child policy map. For the next class, I'm going to remark this traffic, and then I'm going to call the policy map, the child policy map. For the next one, I'm going to do the same. So I am just doing the same as the table map is doing, but manually. And I am just making sure to call the child policy map at any case. So I will have to repeat this line because I have to make sure to call the child policy map whatever happens. So in order to do that, also for the class default, I'm going to call the child policy map. So now that I have that, I can go into gigabit 2. If you notice, gigabit 2 is where the traffic that comes from network V will arrive into network A. I'm going to attach the policy map in the input direction. That will be my parent mutation policy map. So this is how it is configured. So run interface gigabit 2. It is going to do this. And my policy map will be this parent mutation. So I am going to identify the traffic and remark it and call the child policy map. Identify the traffic and remark it and call the child policy map. Identify the traffic and remark it and call the child policy map. So I am remarking traffic and making sure to call the child policy map at any single case. it is the configuration is a little bit more complicated than when using table maps. I'm going to do the same at this router V. So I'm going to create several class maps. The first class map will identify traffic that arrives marked with CS1. So I could use whatever name I want here, but just to be able to recognize my class map, I'm going to call it CS1. And this is going to match all traffic that arrives with with the mark CS1. And then I'm going to create this class map that will match all the traffic that arrives with CS2, and then this class map that will match all the traffic that arrives with CS3, and then these, and so on. So then I'm going to create a placeholder, just and this policy map is there, so you can do whatever you want for quality of service. But we are going to actually do the mutation in a parent policy map. So I'm going to use every single of my class maps, and I'm going to remark the traffic. And then I'm going to call the child policy map. Make sure it gets called, because remember, in your child policy map you can do whatever you want, and you have just making sure that it is getting called in any situation. So I'm going to remark and call the child policy map. Remark, called policy map. Remark, called child policy map. Oops. 41. And then I'm going to remarked, and just for all the other traffic I'm going to use class default and make sure that in that case the child policy map gets called. And then I'm going to attach this into gigabit 2 with service policy in the input direction parent mutation. So that will be the configuration. Gigabit 2 has this input policy map. The policy map will be this. Remarked, 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 remarked. And make sure to always call the child policy map. Same with this. So let's test it. I'm going to fire up here capture and network A, and a capture here and network V, to see how the markings are working. So I'm going to go into this router that is going to simulate an application, user A, and I'm going to send traffic to user V. So I'm going to, for instance, I'm going to ping user V, which has this IP address, but I'm going to use a TOS value here. My TOS values are here in this table. So I'm going to send this traffic mark with CS5, which has an equivalent of 160 in TOS terminology. So let's see the capture at network A. It is CS5, marked as CS5, and at network V, it is marked as EF. So the remarking is working. Let's do the same in the opposite way. And now going to send traffic from network B to network A with the toss value of 106, 184, which is the equivalent of EF. So 184. And let's see the capture. This is for network B. It goes as EF. And at network A, it arrives as CS5. So the marking seems to be working. Let's do another example here. I'm going to send traffic from network A to network B with CS3. So CS3 has a toss value of 96. So let's see now the captures here for network A, CS3, and for network B, it arrives as AF31. It is working, so far so good. So let's see some statistics. So if I issue here at router A, show policy map for interface gigabit 2, these are my marking statistics. I can see, for instance, that I marked some EF traffic. I have some EF traffic that matched this class map for AF31 also. For the other traffic, I have still 0 packets because I just sent test with AF31 and EF. So I only see AF31 and EF. AF41 is in 0. So let's see the traffic here. The statistics here show policy map interface gigabit 2. So I can see for the class default 0 bytes. For CS5 I see traffic because I only did a test with CS5 and CS3. CS4 is 0. CS3 has packets. So you can use this command in order to see real-time statistics for each of your class maps. That's it.